Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 29, 2026, about 6 days ago. It details a semi-autonomous system that screened roughly 700 open math conjectures, successfully resolving 13 of them by either generating new proofs or identifying overlooked solutions in the literature. The paper is titled Semi-Autonomous Mathematics Discovery with Gemini, a case study on the Erdos problems. And as we'll see later, the distinction the authors make between mathematical difficulty and obscurity is really fascinating. Alright, Table 1 details exactly how the system, named Alethea, achieved those results across 13 instances. The first category, autonomous resolution, covers two cases like problem 1051, where the model generated a genuinely novel solution. Then, looking at literature identification at the bottom, we see 5 instances where the AI simply flagged that a problem was already solved, which really underscores that issue of obscurity. In between, the table lists cases of partial solutions and independent rediscovery of existing math. So, while the previous table highlighted the wins, Table 2 breaks down the accuracy for all 200 human-graded responses. The top row shows that the vast majority, 137 candidates, were fundamentally flawed. However, the most interesting finding lies in the gap between the middle rows. Even though 63 solutions were technically correct, only 13 were meaningfully correct, because the model often found trivial proofs that technically worked but missed the actual mathematical intent. Well, Figure 1 maps out that complete filtering pipeline visually. It begins on the far left with the raw input of 700 open problems. The AI agent Alethea acts as the first sieve, reducing the pool to 200 candidate solutions. From there, human grading isolates the 63 technically correct answers, which expert mathematicians finally distill down to the 13 meaningful contributions on the far right. Now, Table 3 places these findings in a broader context by listing all novel autonomous results known at the time. The bold numbers, like 1051, highlight the specific contributions from this paper's agent. However, notice the many asterisk entries in the autonomous resolution row, such as 205 and 401. These mark problems solved independently by other groups, which demonstrates that multiple AI systems are simultaneously reaching the level needed to harvest these accessible conjectures. Okay, to understand what a partial solution looks like in practice, here's the problem statement for Erdos 935. The text first defines the powerful part of an integer, denoted as q2 of n, which involves prime factors with exponents of 2 or higher. Below that definition, the conjecture splits into 3 separate questions about asymptotic behavior. This multi-part structure explains the classification. The AI agent successfully resolved specific components of the problem without proving the entire set of claims. Wrapping up, 2 takeaways stand out. AI agents are proving incredibly effective at clearing low-hanging fruit where problems remain open due to obscurity rather than difficulty. However, the risk of subconscious plagiarism means expert oversight remains crucial to ensure these solutions are truly novel. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.